Hello. I hope you know it's me, by the way. It's Dr. Harrington. This is Lecture 6, page 8. So we have higher degree polynomials. So a power function is a function of the form x to the r, where r is any real number. Now this, remember, may not be a polynomial. But if a power function is equal to x to the n, where n is a non-negative integer, it will be a polynomial. So what we have is we have these different cases. So you have, if n is odd, it kind of goes up like that. So for example, this blue one here, I don't know if you can see that's blue, but let me get the blue pen. This blue one here is of the form, say, f of x is equal to x cubed. Okay, and when the power increases, when you get more and more power, it actually becomes skinnier because it's rising quicker. Actually, so this is going to be x to the 5th in this case. Now, what I want you to notice is if you have something like x cubed, right, the endpoints are going to look like something like that. It's going to go up and it's going to go down. If you have a negative in front of the x cubed, it just flips everything. It starts up here, it just flips it. Now, if it's even, same sort of logic applies. For example, this blue one here is x squared, the one we've been doing, x squared. But if this one, this red one, notice how that one comes down. And by the way, that little point is actually negative 1, 1. And this little point here is 1, 1. So this one here is going to be x to the 4th with that one. Now, when it's even, same sort of idea. You can have, like, x squared, for example, will have endpoints that looks like this. And if it's negative x squared, it just flips it upside down. Now let's talk a little bit about some other things, some other little properties. You'll notice that for the odds, you always have the domain is going to go from negative infinity to infinity, and the range is also negative infinity to infinity. So it goes from left to right, all the values. It goes from down to up and has all those values as well. But the evens are slightly different. The domain, again, is everything. And again, this is for all the ones that are even. Like this is for all the odds. This is for all the evens. The domain is still going to be negative infinity to infinity. But now the range is different. Remember, the range is how low do you go to how high do you go. Well, if you go all the way up, it goes at 0, and then it shoots up to infinity. And you include the 0 there. So that goes to 0 to infinity. Okay. Now, let's consider this polynomial here, where I have f of x is equal to x cubed minus, x to the 4th minus x cubed minus 4x squared plus 4x equals x times x minus 1. Now, I actually factored this again, so make sure you write that down. It's actually x times x minus 1 times x minus 2 times x plus 3. And when you look at the graph for this, again, your x-intercepts for this are going to be 0, 1, 2, and negative 2. So these are my actual x-intercepts. Okay? And you also have one y-intercept. Now we will observe the following about the graph of a polynomial degree n. Now remember, the text may be a different page because we have ebooks and we have physical copies and I have the teacher's edition, so page numbers may be different, but it's still in the right section. This is just what it was when I was looking at it. And we have some certain properties. A polynomial of degree n can have at most n minus 1 turning points. So over here, because my n is 4, so again my n is equal to 4, I can actually have at most 3 turning points. Now let's figure out what a turning point is. Notice here it goes down, and then I have a point, and then it can come up, and then back down. So notice how many times it turns, right? It's going down, it turns and goes up, and it turns and comes back down, turns and comes back up. So here I actually have 3 turning points. So I actually have 4 minus 1 turning points. Could have less, actually. Right? It just has at most. See, that's the key word in the actual definition here. Has at most. Can't have any more than that. Could have less, but it can never have more at most. We'll use calculus to actually figure out what these points are exactly. Now the number of intercepts is determined basically by the zeros. So you can never have no more than n. Now in our case, we actually had 4. So if you come back up here, you say, okay, we have n is equal to 4. We actually have 4 intercepts. Again, could be less, but it's no more than 4. Now as far as end behavior is concerned, this just basically says what does the graph look like as it goes to plus or minus infinity, as it gets big or large. And what you do for that, for the end behavior, is you look at the highest degree. So in our example, our end behavior was x to the 4th, which was even. So if you go back over here and you say, well, what happens when it's even? Both endpoints are just going to be sticking straight up. If it was negative even, it'd be pointing, both of them would be pointing straight down. If it was odd, it'd be the opposite that you have. Cool. Well, hopefully that makes sense. I'll see you guys next time.